So 5.2, we went over the 4 basic methods of factoring. Okay, now this last part, we're going to put them all together and then show you how to solve using factoring. Okay, so factoring completely is looking at some more complicated equations. All the equations we did so far, there was one step to, and you only need one of those methods to factor it. Now we're on taking it a step farther, where some of these methods are on be mixed together. When you're thinking of these problems, okay, always think GCF first. This does 2 things. One, it simplifies your equation or expression that you're looking at. So things are on be, the numbers are on be a little smaller, exponents are on be a little smaller, everything's just a little simpler. 2, doing this first, I find it gets it out of the way. If students wait, you can do it later on in the problem, but I feel students always forget to do it later on. Okay? Once the equation starts to get broken down, they forget, okay, I can still take a GCF out of just this one piece. Doing it right away, I feel that more commonly people get the right answer. Once you take out the GCF, and there might not be one, but if there is, you take out the GCF and you start counting terms. So when we were going over those other methods, I was saying, look, there's 3 terms, 4 terms, 2 terms. Well, it's going to tell you what method to use. If there's 2 terms, we're going to look for difference of squares. If there are 3 terms, it's trinomial into 2 binomials. 4 terms is grouping. And for each one of those, you do have to, this is the chance. 3 terms, okay, it might be trinomial into 2 binomials. You have to look at the form and see, okay, does it work or not? For difference of 2 squares, you still have to look, is it subtraction? Are they perfect squares? But the number of terms are going to tell you which method you should think about. Now, for this class, we have 2 terms, 3 terms, 4 terms. Anything more than 4 terms, you're done factoring it. Okay? If you took out the greatest common factor and say there's 6 terms in that expression, you're done for that expression then. Okay? So looking at some examples here, 6x cubed plus 26x squared minus 20x. Okay? First thing is look for a GCF. Looking at this, yes, there is a GCF. We can take out a 2x in this case. And taking out that 2x, 3x squared plus 13x minus 10. And now, so that looks like our distributive property. We took out a greatest common factor of 2x. You kind of need to forget about the 2x for a little bit. Not completely make it disappear, but just for right now, all we want to look at is what's inside the parentheses. 3x squared plus 13x minus 10. There's 3 terms, so I'm going to look and try and do a trinomial into 2 binomials. I'm going to do the work, multiply my a times c is negative 30, and 15 and negative 2 gives us our 13x. 3x squared plus 15x minus 2x minus 10. Going to group those. Take out a 3x, gives us x plus 5. It's negative 2x minus 10, so I'm going to take out a negative 2, which gives us x plus 5. Got to watch those signs for that one. And rewriting this, x plus 5, x plus 5, x plus 5 in the parentheses, so we're good. 3x minus 2. Now, this is why I always say you can't ignore the greatest common factor or make it disappear completely. That 2x is part of our final answer. Okay, so you have to bring that down at the very end. That's a common mistake, is people forgetting about it up top there. That is part of our answer. And that is now factored completely. Okay? So GCF first, and then count the terms. Okay? Doing another example, 60x cubed plus 15x squared plus 40x plus 10. Looking at this, I'm going to take out a 5. There's no x on that 10, so it's not 5x, it's just going to be 5. And we should get 12x cubed plus 3x squared plus 8x plus 2. Just double check my work there real quick. 12, 3, 8, and 2. Okay. Now there's 4 terms. So I'm going to do grouping. Exponents are good. X cubed, x squared, x, and then the constant. So I'm going to group. Take out my greatest common factor of 3x squared. Gives us 4x plus 1. Greatest common factor of 2. 4x plus 1. And looking at this, okay, everything looks good. 4x plus 1, 4x plus 1. 3x squared plus 2. And again, don't forget to bring down that greatest common factor. All right, so there's our final answer for that one. Again, the greatest common factor at the very end, we have to remember to bring that in. Okay, if we forget that, that is a point. If you just multiply the 4x plus 1 and the 3x squared plus 2, we don't get the original problem. Not until you multiply that greatest common factor as well. Okay, so this was factoring completely. Now this is what we're going to have to do when we solve now. You have to factor completely, and there's one extra step to get the value of x. Remember, when we're solving, you are solving to find what x value would make the statement true. Erase this. So solve by factoring. The directions are very important. If it just says factor completely, we don't need to get the value of x. We just need to factor it as much as we can. When it says solve by factoring, we have an extra step to do of finding what the value of x is. Okay, so here we have x squared minus 16 equals 0. So yeah, we're not going to ignore that 0 for a little bit. When we're solving, you have to have an equation. You're solving an equation, you simplify an expression. We're solving this equation, but forget about that 0 equals 0. It's in standard form, so we're good. X squared minus 16. There is no greatest common factor, so right away my account. 1, 2 terms. So we're going to look at difference of squares. Perfect square, so let's do this. Square root of x squared is x. Square root of 16 is 4. We have our subtraction, so x minus 4, x plus 4. So there it is, factored completely. Not too bad for the factoring part. Now the solving part, this is where we're going to get our x values. We have two pieces here, so we're going to solve both those and make them equations equal to 0. X minus 4 equals 0, x plus 4 equals 0. And this is how we're going to get our value of x, solving those equations. Usually the equations aren't that bad. They're usually pretty small. So if we're going through this and solving, x equals 4, x equals negative 4. Equations that we should be able to solve pretty basically. And no matter what, either one of those, if you plug them into the original equation, you will equal 0. These are solving, finding zeros. These are all those ways of getting the x value that would make this a true statement. Okay, you ended up with two answers, just like when we did the parabola. If it hits the x-axis 2 times, you have 2 solutions. Well, in this case, we had 2 solutions for these x's. 4x cubed plus 14x squared plus 12x equals f of x. So again, it's kind of just ignore the f of x for a little bit. It's in standard form. I'm going to look for greatest common factor, and I'm going to take out a 2x. 2x squared plus 7x plus 6. All right, I'm going to move through this kind of quickly. The 1, 2, 3 terms. So we have trinomial. Factors of 12 are 3 and 4 that I'm going to use. Okay, so again, this factoring down, we rewrote the problem. We're going to group them. Take out an x, gives you 2x plus 3. Take out a 2, gives you 2x plus 3. 2x, 2x plus 3, and x plus 2. So there it is, factored completely. 2x plus 3, we have our x plus 2, and I remember to bring down my greatest common factor. Now, for this problem, we factored it, there were 2 groups, 2 binomials. Okay. Over here, we have 3 groups, 3 terms. The 2x plus 3, the x plus 2. 2 parts, 2 solutions. 3 parts, we're going to solve for 3 solutions. Each one of those need to be set equal to 0. 2x equals 0, 2x plus 3 equals 0, x plus 2 equals 0. And again, none of the equations are that difficult to solve. Divide by 2. You got x equals 0. subtract your 3, divide by 2 gives you x equals negative 3 over 2. And the last one, just subtracting the 2. 1, 2, 3 solutions. Okay? So factoring completely. Always make sure you take the GCF out first and then count your terms. Those terms are going to tell you what method to use. If you're told to solve by factoring, take it that extra step farther. Set the pieces equal to 0 and solve those equations. Okay? So that is the end of 5.2 factoring.